Alright, so these are going to be our notes for Unit 6. The idea here is we're working with graphing. We're going to start off with solely linear equations, and towards the end touch a little bit on inequalities. Alright, so notes 1, going to do a good chunk of this together. So our first concept is talking about slope. Slope is known as the constant rate of change between points on the line. The idea here, it's known as variable m. For some reason we just go with that, so again you'll see me use that for slope. Type of slope, if we read, just like when we read books, we always go from left to right. So going left to right here looks like I'm going up. This is what's known as positive. If I'm going down from left to right, negative. A flat line, that's not going up or down. So that's what's known as having a slope, or an m, equal to 0. And here, vertically, that's what's known as an undefined slope. So equations that have positive and negative slope look something like y equals mx plus b. So that's for both of these. If we have a slope of 0, we just have y is equal to some number, positive or negative. And if we have an undefined slope, these are that special case where we have x equals some number, positive or negative. Alright, so given a graph, we're going to go ahead and do a few of these to count on some slope. Alright, so taking a look at number 1. Visually we see that from left to right our line is going up, so I know it's a positive number. Now, when we're counting slope, we always start at the point on the left. So here's the 2 points they gave us. This one's on the left. So when I count my slope, which is defined as rise over run, we're going to start always on the left. So here it looks like I'm moving up 1, 2, 3, 4, 5, 6, 7. So my slope, I went up, so it's positive 7. Now how far did I go to the right? 1, 2, 3, 4. Now, you could check in Algebra to see if that's your good slope. So again, that's something we went over. That's that fraction text command. There I would just do the fraction text, 7 divided by 4, and it's going to spit back out that 7 divided by 4 because that doesn't reduce. We always want to check if our slope's reduced, but in this case it doesn't. Number 2, if I'm looking from left to right, my line's going down. So I know this one should be a negative slope. So looking at my 2 points, I'm starting at the left. Now this time, to go from the point on the left to the right, it looks like I'm going to go down first. Since I got to go down, I know it's negative. Let's say I go down 1, 2, 3, so it's negative 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if we check this one in Algebra, we'll find out it reduces to negative 1 over 3. When we're working with slope, we will only write fractions. There are no decimals with slope. So, make sure you're leaving everything in fraction form. Looking at number 3 here. So here's the line we're given. Now, right off the bat, I see this as a horizontal line. So, anytime we have a horizontal line like that with no slope, we know our slope is 0, because we're not going up or down at all to get to the next point. Here, we have a vertical line. So, I'm just going to keep going up, but I don't go over at all. That's where we say m is undefined. Definitely items that, how to count the slopes here being that 0 and undefined, those are note card items. The rest of these will be left up to you as practice. Now let's take a look down here. Now, sometimes we aren't given a graph. And rather than graph everything out by hand and count, we can also use a formula. So the formula we're going to use, y1 minus y2 over x1 minus x2. You may have seen this formula written the other way. I just prefer doing it this way as I think it's a little bit easier to work with. Alright, so here we have x1, y1 x2, y2. So using our formula, let's see, we have the y's on top. The y always has to go on top. That's just how we count it, because y deals with the rise, the up and down. So y1 minus y2, well, let's see, that's 1 minus 3 over x1 minus x2. Now, this is something, if you type it in GeoGebra, so if we use this, so if I wanted to do this thing all at once, and again, this is totally a note card item, here's the answer we should get. So we should end up with -2 over -3, which will reduce to 2 over 3. Now, if you're someone who's not particularly strong at reducing those fractions, here's how you could type it in GeoGebra. And again, totally a note card item. So we're going to use that fraction text command. And then in here, I'm going to type it just how it looks. So 1 minus 3 in parentheses, divided by 1 minus 4 in parentheses. Doing that, it'll actually go ahead and simplify for you. Let's take a look at number 3 here. We had some negatives. Alright, so using my same type of formula here. So I have y1 minus y2, so 5 minus, remember, anytime we have a negative, it gets its own set of parentheses, just like in previous units. Divided by x1 minus x2. So negative gets its own set, negative gets its own set. Typing into GeoGebra with all of those parentheses. So our fraction text. So here, I'm going to go ahead and use a different color, just to kind of show you exactly how this whole bit looks in the separate part of the command. So notice all those parentheses I wrote. I just type it into GeoGebra. It's going to do it for me to make sure I don't make any mistakes. So this is what we would type into GeoGebra. And our answer here, we would get 10 over 4, which would reduce to 5 over 2. So try that now. GeoGebra will also tell you if you get an undefined slope or a slope of 0. So the rest of these problems on this page are part of your guys' practice. So at this time, go ahead and complete the rest of these problems now. Once you've done that, move on to 2. You know what? We can go ahead and skip 2. So, on your timeline, it says all problems on notes 1. I do want you guys to make sure you finish all those, but you don't need to worry about completing 2 at all. So once you complete with 1, you guys can go ahead and move on to 3. Alright, so on to notes 3 here. So we're going to do a good bit of this together. Alright, so now we're looking at slope of a line and describing the graph here. We're looking at from a table and graph. So, when we're given a table, we can kind of use any points because a line is constant, so it doesn't matter which points I look at. So I'm going to use, let's say these ones. I'm going to use this and this. So these are the ordered pairs, negative 168, 140, and 14, 10. So setting up my slope, subtracting y1 from y2, that's 140 minus 10 over negative 168 minus 14. So again, bigger numbers, definitely check it in a calculator. Or GeoGebra, obviously. So our fraction here we'll get is negative 5 over 7. Describing that slope? Well, it's negative, so on a graph, it would look like it was decreasing or going down from left to right. Let's go ahead and take a look at this graph. Now, the key idea here is we want to pick good points. So what I would say by good points is, let's look here. This point, it's on the line, but can I really tell exactly what numbers that's at? Not really. But if I look here, it's kind of crossing at those grid lines. So I could easily say that the coordinates at that point are 1, 20. Probably not the best one. No, but here's a good one. It's at 2, 40. So using those points to find the slope, let's see, y minus y over x minus x. Here we get a nice whole number of 20, or 20 over 1. Either way, writing that answer is fine. It's positive, so this is definitely an increasing slope. Alright, from there, you guys have completed 3. So let's jump on to 4. So, the key words here is what the thing we're looking for. You're going to find slope for each of these using any 2 points you like. And then you're going to tell me, is it increasing, decreasing, so that's positive, this is negative. Horizontal means the slope is 0, and vertical means our slope is undefined. So, you're completing each of these, as well as identifying that. Once you've completed that, head on to 5 for some more notes. Alright, so looking at some of our applications here of slope. The big idea concept is we're going to construct a linear equation and graph those linear equations. So, we're actually going to go ahead and take a look here. We're going to skip over some of these. So, let's see. Let's go ahead and jump down here. Alright, so we're going to zoom in a bit so we can kind of read easier. So here we're given a graph. And what we want to do is go ahead and read this story that goes along with it. And I'm going to go ahead and label the graph with various parts of the story, kind of bringing that picture to the question in hand. So Tommy starts his errands by driving at a constant pace to pick up his brother from school. Well, what that means is I'm going from here, right? So here's my starting point. So we talked about in the previous unit. We always start, our x-axis represents like our home base. So here is where I'm going to go pick up brother. So this part of the line is picking up brother. He makes his first stop where he picks up his brother from school. So stopping means we have a horizontal line, right? A slope of 0. So this is a stop. Let's see here. Tommy drives half a mile for 1 minute, but has to stop at a traffic light. So here he's driving again. And then we see that stopping point up here. This is the stoplight. Tommy and his brother drive home. He stops at home for a total of 4 minutes. So again, we're decreasing. So this is going home. And we're on the x-axis, so we're at home and we're not moving. So here we're just home hanging out. After Tommy returns home, he decides to go to the library to return a book. Tommy drives back home because he realized he forgot the book. So now we're going farther away. So this is to the library. And here, we're going home again because he ended up forgetting that book. So that's taking this paragraph and associating it with various parts of our graph. Now, some other things we can get from this graph. The speed. A scalar quantity that refers to how fast an object is moving. It is not direction aware. So this is the distance traveled divided by how long it took. So that's the velocity. Or that's the speed we're going. So speed has no negative or positive. Velocity, it's the rate at which moving, or the rate at which an object changes its position. This is direction aware. So we're going to use slope to find velocity. So delta, this nifty little symbol in here. So if we look here, we have delta position. That means our change in the distance. So we could think of distance final minus distance initial over time final. It's saying delta time minus time initial. This is the same equation as we've been using the whole time, just using some different letters. So we're still finding a variation of slope. So for question 1, I'm going to calculate the velocity of the car when Tommy began his errands. So that's here. So the 2 points I'm looking at are where he began and where he started his errands. So before he stopped. So those 2 coordinates are 0, 0. And, so this is 0, 0, this is, let's see. Looks like it's right in between 2 and 4, so it's at 3 and 1.5. So for the velocity here, or you can write it as m, either way is fine with me. Let's see, we have y minus y over x minus x. So, calculator, we end up with 1/2. So his velocity there is 1/2. So as the slope's going up, velocity is positive. If the slope is 0, what happens to velocity? Well, let's see. His first stop to pick up his brother, well, that's from here to here. So now we're looking here to here. That's where he picked up his brother from, so we're using these points. So we have that 3, 1.5 now. And then 6, 1.5. So our velocity, or again our slope here, y minus y over x minus x. Here we'll get 0. So if the slope is 0, velocity is also 0. And he turns around to go back home after he forgot his book. Well, that's the last part of our graph here. So these would be the points 30, 0 and 26, 2. So, calculating our slope here. Here, little GeoGebra, little calculator, we're going to end up with negative 1/2. So, as the slope goes down, the velocity here is negative. Alright, little adjustment to your guys' practice here. This is the problem you're going to complete for homework. So, when you complete that, that'll have completed all the problems here on 5, and I'm actually going to let you guys skip over 6. So we'll be skipping 6, but you do need to complete that problem on 5. So we're completing this last problem here is homework. Once you've done that, we'll move on to 7 for some more notes. Alright, up until this point, most of the stuff we've covered in here should be stuff you've seen before. Now, this might be a little bit new to you, so make sure you take some very detailed notes in this section. First thing we're going to start off is our 2 forms of linear equations. We have slope-intercept and standard form. Let's start with slope-intercept. Here is our y equals mx plus b. M stands for the slope. B is what's known as the y-intercept. So, here, we're given what those things are. So, y equals something x. Y equals something x. That's going to be kind of your generic setup. Y and x are just variables. So, if my slope is 2, that means my m is 2. My y-intercept, my b is negative 1, so it's minus 1. My m here, negative 3 over 5. My b, my slope is positive 4, so it's going to be plus 4. So following that same pattern, let's go ahead and fill out the rest of these. So m is always the thing that's going first. Then m also goes with our variable, so m is always multiplied to our x. Then for our b's, those are our y-intercepts. So here it's a positive 2, so it's plus 2. Positive 7 plus 7. here it's 0. Now you don't necessarily have to put the plus 0 at the end, but I don't mind if you do, just so it's doing the same thing. Here our y-intercept is -3, so instead of plus 3, I throw a minus 3. Alright, now, standard form, tad bit different. This looks like ax plus by is equal to c. In this one, x and y are variables, a, b, and c are just numbers. But it's kind of hard to graph in this. So what we like to do is rewrite it. So the goal in each of these, to get into slope-intercept to make graphing easier, is we're going to get y by itself. So here's my y. So the first thing I do in every one of these examples is move my x. Well, I want to get x over here. The opposite of positive would be negative. So I'm going to subtract 2x from both sides. I'm going to bring my y down. Well, these cancel. Now, these are not like terms because this has an x and this doesn't. So I can just write it. We're always going to put that m, or our variable term, first. So negative 2x. That's a positive 3, so plus 3. For that one, we're done. Y is already by itself. Moving on to number 2. Okay, still move my x first, so I'm going to subtract 4x because it's positive, so that's the opposite. Now I have a 5y, and it's plus, so it's a positive. Negative 4x. This is negative 30, so it's minus 30. Now, I can't have anything in front of my y when I graph using point-slope form. So I'm going to divide everything now by 5. Those go away, so I have y equals negative 4 over 5. Check with your calculator, check with your algebra. It doesn't reduce. So it just stays negative 4 over 5x. Here, negative 30 divided by 5. Checking, it does reduce. That's just minus 6. So that would be our final answer there. Here, same thing, move my x first. So if there's just a letter or just a variable, it's like having a 1 in front. So here I'm going to subtract 1x from both sides. Now it's minus 3y, so that means I'm bringing down a negative 3y. And again, positive 12, so plus 12. Now I got to divide everything by that negative 3 to get just y. Calculator, we find out that's 1 over 3. 12 divided by negative 3 is minus 4. Looking at number 4. Subtracting my 1x here again. Bringing down my negative y. Now, trick here, you got to make sure it's just y. So to get rid of that negative, it's like having a negative 1. I'm going to divide everything by negative 1. To get my final answer. From here, we'll just do these last two real quick as a quick reference. Now I'm going to go ahead and leave it as saying plus 0. You don't need to, but again, it's not going to hurt anything. So there's our answer there, and again, the plus 0 is optional at the end. And for our last example, set of notes. There we go. So, once you've worked through these notes, you should have a pretty good understanding of the difference in the forms. What I want you to do is go on to 8. Here, you'll be completing all of these problems. Once you've done that, we're going to move on to 9 for some more notes. So taking a look here at number 9 for some notes, here we're going to start graphing. So the key idea is we need it in slope-intercept form to graph. We plot the y-intercept, our b, and we use the slope to get our next set of points. Alright, taking a look here at number 1. Alright, y is already by itself here, so I'm in slope-intercept form. So if I look here, my b is the thing at the end. It's just the number, and it's positive 3, so b is just 3. My m is what's out in front of the x. Well, here it's just a negative, so it's like having a negative 1. Now, anytime you have a whole number, we're always going to think of it as being over 1. So even if it's a negative number, we always put it over 1. So first thing I do is I plot my b. It's positive. B always goes on our y-axis. So it's positive 3, so 1, 2, 3. Now, to get my slope, well, negative means I go down. So from b, you have to start where you plotted b. The negative on top tells me to go down. So let's think about this. For our m, if we have our fractions here, so on the bottom, positive means to the right. Negative means to the left. On the top, positive means up. Negative means down. So this means down 1, right 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. You want to try and get a few of those points on there. It just makes your line look a bit neater. Now in some of these graphs you may be only need to fit one other point. That's fine, but if you can fit more than one, I would suggest doing it. Let's take a look here at number 2. So here my b, it's minus 4, so it's going to be negative 4. My slope, it's 3, and it's a whole number, so I'm going to put it over 1. So first I plot b, that's at negative 4, so on the y-axis, 1, 2, 3, 4, so it's negative 4. Now it's 3 over 1, so positive means up, positive means right. So I'm going to go up 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. So I can get another one even, 1, 2, 3, 1. And again, you may not always be able to fit that many points, but the more the better. Let's see here. Let's go ahead and do one more of these up here. Let's try 8. So we'll do all 3 of these together. First, let's start with 7. Okay, so here, my b, negative 4, my m, there's nothing out front, so it's just like having 1 over 1. So I start at negative 4, so 1, 2, 3, 4, so negative 4 because I went down. And then my slope, up 1 over 1. Up 1 over 1, up 1 over 1. Here, our b is positive 3. My m, whenever you have a negative out front, always just put it with the top number. So negative 1 over 4. Again, that negative does not go with both. So if you have a negative, just put it with the top number. So our b, positive 1, 2, 3. Now my slope, down 1, right 4. So down 1, right 1, 2, 3, 4. Now here, I see I can't fit it. So we're going to talk about a special case where we do the opposite. To get another point. We always want to get at least 3 points on these graphs. So the opposite of going down 1, right 4. So the way I can get a point in the opposite direction but still having that same line would be doing the opposite of this slope. So instead of down 1, I'm going to go up 1. And instead of right 4, I'm going to go left 4. So up 1, left 1, 2, 3, 4. You'll notice it still gives me that same line. So using the opposite is something you'll have to do to get those more points. Now, if we go to this y equals here, notice I don't have something I'm adding. So that's like adding 0. So here, b is just 0. My slope, 4 over 1. So my b, 0 on the y-axis means here. So up 1, 2, 3, 4 over 1. And let's go ahead and use that opposite again to get another point. So here I went up 4, right 1. So the opposite of that, well, the opposite of up is down 4. And the opposite of going right would be left 1. So now down 1, 2, 3, 4, left 1. So again, whenever you're graphing, you want to get at least 3 points. Sometimes you might not need to, but a lot of times you're going to have to use that opposite. So make sure you're comfortable with it. Definitely a note card item. We'll do 2 more of these together. So we'll do 14 and 15 together as well. So first thing we're going to notice here is that these are not in slope-intercept form. I can tell that because y is not by itself. So, just like in the last set of practice notes, let's get it by itself. So I'd subtract 4x from both sides. Don't need to write the plus, it's just positive. Divide everything by 3. And I get y equals negative 4 over 3, because that doesn't reduce, plus 4. So that means my m is negative 4 over 3, my b, 4. So let's plot our b, 2, 3, 4. And then my slope, well, this means negative on top, I'm going to go down 4, positive on the bottom, right 3. So 1, 2, 3, 4, 1, 2, 3. If I want to get another point, well, it's not going to be perfect, but we can go ahead and estimate one to the right here. Down 1, 2, 3, 4, right 1, 2, kind of out there. So again, if your graph's not big enough, you can estimate that third point. Alright, on to here. So for this one, we're going to subtract 2x from both sides again. I got negative 4y is equal to negative 2x plus 8. Dividing by my negative 4. So, my b, negative 2. My m, 1 over 2. So let's plot that negative 2. Now this means I'm going up 1, right 2. So up 1, right 1, 2. Up 1, right 2. Let's go ahead and use the opposite as well here. So the opposite of going up and right would be down 1, left 2. So down 1, left 2. Down 1, left 2. And we get a great line there. From that, what you're going to go ahead and do here is complete the rest of the problems on 9. So take your time, work through them all, and when you've done that, we're going to move on to number 10 for some more practice. Okay, so on number 10 here, we're going to do numbers 1 through 4 together. Alright, so to write an equation in slope-intercept form, y equals mx plus b, all we need to find is our slope m and our y-intercept b. So let's go ahead and take a look at these graphs. Now I'm given 2 points here. So I can use those to get my slope. Just like in our first set of here, we're always starting at the point on the left. So from the left, I'd go up 1, 2, 3. So my slope is positive 3 because I'm going up over. Well, I just go right 1. So it's also positive. My b represents where I cross the x-axis. Or the y-axis. So this is the y-axis. And it looks like I'm crossing right here. So that's at the point negative 1, 2, 3. So it's negative 3. So my equation, y equals m, or you could just put 3 there, either way is fine. X, it's negative 3, so minus 3. For number 2, looking at our slope, so again they gave us 2 points, so I'm counting from the point on the left to the point on the right. I'm going down, so it's negative 1, 2, 3, over 1, 2. 1, 2. So it's negative 3 over 2. B is where we're crossing the y-axis. It's right here again. So it's at positive 1, 2. So my equation, m, x, and it's a positive b, so plus 2. Now here we don't have our setup, but we still know we need to find m and b. So for each of these problems, your first step is to identify m and b. Looking at the 2 points they gave us here. So from left to right, I'm going up, so I know it's going to be a positive slope, so up 1, 2. So let's go to the side here. Going up 2, and then I go right 1, 2, 3, 4, 5. I check. 2 over 5 doesn't reduce. So I'm good there. That's my slope. My b is where it's crossing the y-axis, which is here. That's at 1, 2. So it's positive 2. So my equation, y equals 2 over 5x plus 2. Moving on to 4. Again, we go from left to right. So it looks like I'm going down, so I know my slope's negative. Down 1, 2, 3, so it's negative 3. I go over 1, so over 1. My b, where it's crossing here, is at positive 1. And again, here you could just write negative 3 as well, but if you want to keep it over 1, that's totally fine with me. What you're working on now is completing the rest of these problems. So get your slope, get your b. Let's not worry about 13 and 14. So just work through 12. Once you're done with that, you've completed section 10. We'll be moving on to 11 for some more notes. Alright, so for 11 here, we're going to complete a good chunk of these together, and then you guys will be completing some for practice. Okay, so special cases. These are vertical and horizontal lines. So if a vertical line is written in the form x equals a, where x is just a number, it's where it crosses the x-axis. Horizontal is y equals a, so kind of like we referenced earlier. Vertical is x equals some number, horizontal, y equals some number. Here our slope is undefined, here our slope is just 0. Alright, so first thing, this is a vertical line, it's going up and down. This horizontal, it's a flat line, it's going left and right. So vertical means I got x equal. Horizontal, I know I have y equal. If we look, this line goes through the point, well, negative 1, negative 2. So this is x is equal to negative 2. Here, it's going through the point 1, 2, 3. So this is y equals positive 3. For these ones, horizontal, that's y equals. Vertical, x equals. So this one will be going through negative 1, 2, 3, 4, 5. So this is y equals negative 5. Here it's going through positive 1, 2, 3, 4. So this is x equals positive 4. Again, this is just one of those things with practice, you'll get down path. So 5 and 6 will be left as practice problems. 5 does not have a very good line in here, so let's go ahead and make it this line. So for 5, go ahead and use this red line here. Alright, we'll graph 2 of these as well. So graphing y equals, well, y equals, that means I'm horizontal. X equals means I'm vertical. So if I go through y equals negative 5, it's horizontal, that means I get this line here. Vertical, x is negative 1, so I'm at x is negative 1, and it's a vertical line, so it's going straight up and down. The rest of these problems are left as practice. So go ahead, and we're going to work through all of these here. Once you've completed that, you can move on to 12, which you'll complete for homework. Notice this is a bit of a review, so ignore the directions here. You are just completing this on your own. So, once you've done with this, you can move on to 13 for some more notes. Alright, we're actually going to skip around a bit here just to kind of make this unit go a tad bit quicker for you guys. So we're actually going to skip 13 altogether. So let's not worry about that. 14, we're going to do, but we're going to make some adjustments. We're actually going to skip 15 and 16 too. So let's go ahead and make sure we know we're skipping these. And for 14, we're going to make it a little different. Okay, so we're going to ignore these directions. Everything we're going to do is going to be slope-intercept. So for these examples, we're going to be given some information. So we're given our slopes, we know our m, we know a pair, an ordered pair on the line, an x comma y. So what we don't know is our b. So let's start off with our equation y equals mx plus b. Well, I know what x and y are. They're giving me an example of them. I know what m is. So let's go ahead and plug all that information in. So my y is 1, m is 2, x is 4. We don't know b. So to solve this, I'm going to multiply these numbers first. That'll give me 1 is equal to 8 plus b. To get b by itself, I'm going to move that positive 8 over, so I'm going to subtract it. So I find negative 7 is b. So my final answer, y equals m is 2, so 2x minus 7. Here, for 2, we have our x, our y, and our m. So starting with y equals mx plus b, let's plug in. Y is 4. M here is 1/2. Our x is 2. And we don't know b. So multiplying these two first, that gives me 1. Subtracting it from both sides tells me that 3 is my b. So my equation in slope-intercept form, y equals m x, and it's positive 3, so plus 3. Now I want you guys to do 3, 4, 5, and 6. So pause the video at this time and go ahead and work through those problems. It's doing the same thing as the first two examples we just did. Once you've completed that, we're going to move on down here. So again, we're just going to start with our y equals mx plus b. So we'll do 2 together, and then 9, 10, 11, and 12 will be left as practice. So, first thing we're going to do here for 7a is we're going to find the slope. So here we're not told what the slope is. So we know to write in y equals mx plus b, we need the slope. So step 1, we're going to find our slope. So just like before, it's y minus y, so y1 minus y2. So 7 minus negative 1 over x1 minus x2. Again, giving my negatives their own set of parentheses. Here, we'll find our slope is negative 2, or negative 2 over 1. Now that I've found my slope, I'm going to go ahead and do it for the second example too, because that's our step 1 for both of these. I'm just going to try to color coordinate a bit here. So the red exemplifies our step 1. So, in both of those, you should have found those slopes. Now, step 2, I'm going to do in blue. Now, just like in those previous examples, now we have a slope and some points that it goes through. So we're going to go back to y equals mx plus b. Again, that second piece of information besides the slope that we could need to find is just our b. So you can use either one of these points. I just use the one where the numbers look smaller. That's just me. So here 1 is smaller than 3 and so on and so forth. So I'm going to use this one. You could use the other one. You'll get the same answers. So now I have my x and my y. And I have my m. So I'm going to plug in. Y is negative 1. M, negative 2. X is 1. I don't know b. So solving just how we did above. Here it's negative 2, so I'm going to add it to both sides. So 1 is my b. So my final answer, y equals m, negative 2x, positive 1, so plus 1. For 8, we can again use either point. Well, 3 and 4 look smaller than 6 and 7. So here's my x and my y. So I'd have negative 4 is equal to m, which is 1 over 3, times x, which is 3, plus b. So my final answer, y equals m, x. It's negative 5 for my b, so I'm minus 5. At this point, you're going to complete the rest of the problems on notes 14. As I mentioned earlier, we're actually going to go ahead and skip 15 and 16. Also, if you take a look at the study guide, I kind of crossed out some stuff here at the bottom. So we won't be doing anything with standard form or inequalities, just to kind of make this test shorter. And you'll see there's also an answer key at the bottom here to check your work as well. So, once you've completed the Unit 6 review and checked in with me, your last assignment for Unit 6 is to pass that Unit 6 exam.